Okay, so this should be a quick summary video on how to do mole calculations based on balanced equations. So whenever it comes to these, you need to know your three triangles. From Nat 5, you know that the number of moles of a solid is equal to the mass divided by the GFM. From Nat 5, for solutions, you know that the number of moles is equal to the concentration multiplied by the volume in liters. And then in higher, you were introduced to molar volume of gases and that the number of moles of a gas is equal to the volume of that gas divided by the molar volume. And you'll always be given molar volume in the question. When you have the number of moles of one chemical from a balanced equation, you can use the mole ratio to work out the number of moles of any other chemical. There are 4 steps for answering any of these types of questions. So the first step is to look at the question, look at the equation, identify what are the chemicals that you care about and what information do you know about them. Step 2, calculate the moles of one of the chemicals. Step 3, use the molar ratio to work out moles of the other chemical. And step 4, now that you know the moles of the other chemical, you'll be able to answer the question. So I'm going to work through one past paper question to show you this method in action. So we've been told a sherbet, so just a sweet, is made by mixing 15 grams of sodium hydrogen carbonate with excess citric acid. And you've been given the equation. And with that equation, what you have is C6H8O7, then we've got 3 sodium hydrogen carbonate, then we've got this other chemical, which I'm assuming is the sherbet, then we've got 3 water and 3 carbon dioxide. And the question has asked you to calculate the maximum volume of carbon dioxide that would be released from this sherbet. So that is the question that you're going to answer in the final step. And you can see that you've been given the volume of 1 mole of carbon dioxide is 24 litres. That means that 24 is the molar volume. So step 1, what are the chemicals we care about and what do we know about them? Well, from the equation, the chemicals that we care about, well, that's going to be here because we've been given the gram formula mass, and then we've been asked to work out the CO2. So that means what we can do is we can cancel out all the other chemicals and we do not need to worry about them. And on your test paper, when you are able to do one, you'll do that. Next, what we'll do is we will write down everything we know. Right, so from the question for sodium hydrogen carbonate, we know that the mass of 1 mole is 84 grams. So mass of 1 mole, that is the GFM, and that is 84. We also know from the question that we have got 15 grams. So M equals 15 grams. For our CO2, we know that we want to work out the mass, and it's carbon dioxide, so it's a gas. So what we know is just the molar volume, which is 24. Okay, so from that, we can now move on to step 2. Step 2 is calculate the moles of one of the chemicals. Well, we've not got enough information for carbon dioxide, but we have got a mass and a GFM. So we can do N equals M divided by GFM, which is 15 divided by 84, which comes out to be, it's quite a long number on the calculator, it's not a nice round number. I am going to write it with 5 numbers after the decimal point. So it's 17857. It does go on longer than that, but I like to keep about 5 after the decimal place if possible. Do not round up. So really do not round too much. If you round too much, your answer can be too far away from what they are expecting. But we have got our number of moles. So we have done step 2. Our next step, step 3, is to work out our molar ratio and then work out the moles. So from the molar ratio, we've got a 3 here and we've got a 3 here. Now that can be simplified 1 to 1, and we had 0.17857 here, which means we'd have the same number here, 0.17857 here. So we've got that, we've done step 3. Final step is to answer the question. So what we've got, if we've got our number of moles, we've worked that out from the molar ratio, and we've got our molar volume. Now for working this out, volume is equal to number of moles multiplied by mole vol. So that's going to be 0.1, sorry for my writing here, 857 multiplied by 24, which gives us 4.28568. And this is where I would round up, and I would round it up to 2 decimal places, 4.29 litres. We've answered the question. So that has covered all the steps necessary, and that's how to do a question like this. Finally, I'm just going to go over some helpful hints for any other questions related to this. First one, make sure if you're given any volume, you turn it into litres. And to turn centimetres cubed into litres, you divide by 1,000. Second thing, remember, even if you completely forget how to do these, you can sometimes get a mark for just the molar ratio. Sometimes you have to use the molar ratio to get that mark. But remember, write the molar ratio down. Step 3, you only need to calculate the GFM if you're asked for the mass of a chemical. So do not immediately go in there and waste time calculating GFM for every chemical. Look and see, is it a mass you're after? And finally, check with volume, because volume is involved in solutions and in gases. So look for the chemical symbol to see whether it is a solution or if it's a gas. If it is aqueous, that means it's a solution, and you're going to use N equals C times V. If it's a gas, you're going to be using the equations relating to molar volume. So hopefully that's been a quick go through with some hints for how to approach mole equations based on balanced equations.